बच्चों अब आते हैं ऑक्सीडेशन स्टेट पे। नाउ ऑल ट्रांजिशन एलिमेंट्स एक्सेप्ट फर्स्ट एंड द लास्ट member of series show great variety of oxidation state. This is because of very small energy difference between the energies of n minus 1d and ns orbitals. Therefore, both energy levels are used for bond formation. ns के electrons और n minus 1d के electrons, both of them take part in bond formation बच्चों. Here basically दोनों के दोनों, क्योंकि ns के electrons और n minus 1d के electrons, both of them are taking part in bond formation. That results in lot of oxidation states. नहीं तो नॉर्मली अगर सिर्फ ns के electrons were taking part, तो your oxidation state must be +2 only. If मैं लिख देता हूँ, if only ns electrons take part in bond formation, +2 oxidation state is obtained. However, because of n minus 1d electrons, higher oxidation state, higher oxidation state like +3, +4, +5, +6, even +7 are obtained. Because of removal of electrons from ns and n minus 1 d orbitals बच्चों. क्लियर है यहाँ तक? पहले इट वाज नॉट दैट क्लियर कि हाउ n minus 1 d electrons result in higher oxidation state. तो मैंने आगे लिख दिया है, because now there can be removal of electrons from not only ns but n minus 1 d बच्चों. Electrons can be removed from Ns as well as N-1d, resulting in large variety of oxidation states. Most common oxidation state of 3D series is +2, except for scandium, for which oxidation state is +3. ठीक है बच्चों, स्कैंडियम के लिए स्टेबल ऑक्सीडेशन स्टेट इज +3, जबकि अदर एलिमेंट्स के लिए मोस्ट कॉमन ऑक्सीडेशन स्टेट इज +2. स्कैंडियम के लिए +3, अदरवाइज +2 इज द मोस्ट कॉमन ऑक्सीडेशन स्टेट. Number of oxidation state shown by elements first increase till middle as number of unpaired electrons increase. After that, it starts decreasing. After that, it starts decreasing as electrons start getting paired. पहले नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स बढ़ते जा रहे थे, तुम्हारा ऑक्सीडेशन स्टेट शोन बाय एलिमेंट्स भी बढ़ता जा रहा था. नंबर ऑफ ऑक्सीडेशन स्टेट शोन बाय एलिमेंट्स बढ़ता जा रहा था एज द नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स वर इंक्रीजिंग. मिडवे के बाद it starts decreasing as the electrons start getting paired up. At other end, zinc shows only oxidation state +2, since no d electrons are involved in bond formation because of 3d10 configuration. Now, maximum value of oxidation state for any transition element is shown in its compound with फ्लोरीन एंड ऑक्सीजन. फ्लोरीन और ऑक्सीजन के साथ मैक्सिमम ऑक्सीडेशन स्टेट देखी गई है ऑफ ट्रांजिशन एलिमेंट्स. ट्रांजिशन एलिमेंट्स अपनी मैक्सिमम ऑक्सीडेशन स्टेट किसके साथ शो करते हैं? या तो फ्लोरीन के साथ या ऑक्सीजन के साथ. एज फ्लोरीन एंड ऑक्सीजन आर as they are small in size and most electronegative. ठीक है बच्चों, transition elements in lower oxidation state like plus 2 plus 3. They form ionic compounds and in higher oxidation state form covalent compounds. ये कहाँ से हम कंक्लूड कर सकते हैं यूजिंग फजान रूल। एग्जाम्पल देखो, मैक्सिमम ऑक्सीडेशन स्टेट उठाते हैं मैंगनीज की और क्रोमियम की। हायर ऑक्सीडेशन स्टेट या हाईएस्ट ऑक्सीडेशन स्टेट में दे आर, इसमें, इन दिस all bonds are covalent. The bonds are covalent. The bonds in these, the molecule as such is, these ions are covalent बच्चों, bonds are covalent. क्यों? क्योंकि chromium and manganese they are present in maximum oxidation state. Because they are present in maximum oxidation state, hence we can say that the bonds are covalent. Next, the elements which show greatest number of oxidation states occur in or near the middle of the series. जैसे manganese, which is almost in the middle, it shows all oxidation state from +2 to +7. The lesser number of oxidation states on extreme ends of the series is either because of two less electrons to share, या तो इनका शेयर करने के लिए इलेक्ट्रॉन्स ही बहुत कम है, शेयर या लूज, और बिकॉज fewer orbitals are available to share them with others, to share electrons with others. या तो इलेक्ट्रॉन्स ही कम है या ऑर्बिटल्स कम अवेलेबल हैं फॉर शेयरिंग विद अदर्स, जैसे कॉपर जिंक। ओके, the highest oxidation state shown by any transition element is plus 8 by osmium. Okay, guys. अब in transition elements, successive oxidation state differ by one odd unity, which is not in the case of other elements. Non-transition elements oxidation state differ by 2 units. जैसे Pb2 plus Pb4 plus. That is one example. Sn2 plus Sn4 plus. The oxidation state are differing by 2 in case of non-transition, and in case of transition elements they differ by 1 बच्चों. Another important thing, in D block elements higher oxidation state are more stable, are more stable for heavier elements. Example, MO plus 6 oxidation state plus 6 oxidation state is more stable than Cr plus 6 oxidation state. Basically, Cr2O72 माइनस, इसमें क्रोमियम की ऑक्सीडेशन स्टेट क्या है? +6. It is a stronger oxidizing agent in acidic medium. Whereas these are not. They are not. They are pretty much stable. These are stable. This is not stable. This can act as an oxidizing agent. In itself will get reduced and it will oxidize some other ion. I mean, this will act as an oxidizing agent. In itself will get reduced and oxidize others. Whereas these are also present in +6 oxidation state, but they are stable. They are stable, बच्चों. In P block elements, it is otherwise. In P block elements, lower oxidation state are more stable for heavier elements because of inert pair effect. In case of D block, higher oxidation state was more stable for heavier elements, whereas in P block, lower oxidation state is more stable for heavier elements. Like in D block, these were stable and Cr plus 6 was not. In this case, in case of P block, let me take an example. Tl, Pb, Bi. In this case, plus 1, plus 2, plus 3. This oxidation state are more stable as compared to plus 3, plus 4, and plus 5. Lower oxidation state is more stable for heavier elements. Got it or not, bachcho? Clear? That's good. By the way, did I tell you when chromium gets reduced, it goes to where? I told you it is a good oxidizing agent. It will get reduced to Cr3 plus. Whereas MOO3, these are stable. Relative stability of transition elements in different oxidation state is also determined by their reduction potential values. It is also determined by their reduction potential values. Example, Cu plus 2Cu. It is more than Cu2 plus 2Cu. Fine, guys. That basically means Cu plus has more tendency to get reduced than Cu plus has more tendency to get reduced than Cu2 plus. Cu plus is reduced more easily than Cu2 plus. Or we can say Cu2 plus is more stable than Cu plus. Cu plus is unstable in H2O. It may undergo oxidation. It will get oxidized to Cu2 plus because Cu2 plus is more stable as Cu2 plus is stable in water. Similarly, Fe2 plus is unstable in aerated water, water in which air is dissolved. It is unstable and it gets oxidized in it as it undergoes oxidation in it. It undergoes oxidation in it. Clear है बच्चों? Now I told you one thing at the start of the lecture that scandium shows the oxidation state of +3 only. Why does it show a oxidation state of +3 only? Because it has got configuration 4s2 3d1. After loss of 3 electrons, it achieves noble gas configuration, which is highly stable. That is why it only shows oxidation state of +3 बच्चों. Clear guys? That's good.